So my name's Ian Hatton. I'm a pre-sales consultant for Zebra EMEA, based in the UK, covering the UK region. And so my presentation today really is talking about how you can quickly do OS updates of Zebra devices using a Wi-Fi Direct hotspot running on one device to update a number of other client devices. And that's the agenda. We're going to look first at an overview of Wi-Fi Direct. We're going to look at the different Wi-Fi technologies we have in our products in terms of the antennas and radios. Then we look at how you can create profiles for use with Wi-Fi Direct, and there's different options for doing that. One of those options is a utility I put together, which we'll cover how you use that. And we'll also look at the hosting device side and the utilities you need to install on the host device in order to set up a Wi-Fi Direct hotspot. We're going to do some demonstrations, hopefully, as part of that. And we'll finish off by modifying an existing package. So if you decide you want to do something different in the update profile, you can modify it manually. So Wi-Fi Direct, what is it? It's formerly called Wi-Fi peer-to-peer, and it's basically a Wi-Fi standard for peer-to-peer wireless connections that allows two devices to establish a direct Wi-Fi connection without an intermediary Wi-Fi access point. So basically, the host device becomes the access point, and you can have a number of client devices connected to it concurrently. It's a single hop communication. So unlike ad hoc networks, the original ad hoc implementation was multi-hop. This is a single hop. And basically the Wi-Fi Direct protocol negotiates the link with a WPA system that assigns each device a limited Wi-Fi access point, wireless access point. So the pairing you can do either by a standard search and connect, or you can also use NFC, for example, an NFC tag to do the pairing, or in our case, we can use a Stage Now profile to set up the Wi-Fi connection on the client device. In terms of antennas, just want to point this out. If you look at our devices, obviously we have a wide range of devices. That's one of the strengths of the company. Is the breadth of the product range, and basically we have devices that have either a single antenna and radio, which is a 1x1 MIMO device. That means that you can only communicate with an access point via a single transmit and receive stream. And we also have devices which are a 2x2 MIMO design, which has a dual antenna and dual radios, and that allows you to communicate with two transmit and receive streams. So effectively your throughput should be at least double with the 2x2 MIMO. And that means more bandwidths available, and the actual download speeds using the 2x2 MIMO is significantly faster. And common analogy is if you had one straw in your drink versus 3 straws, then obviously you can drink faster if you have 3 straws. So simple analogy. As there's more information at that link if you want to go into that in a bit more detail. On our current generation devices like TC52, EC50, we have a 2x2 MIMO design, so that's going to operate at 802.11 AC speeds of at least 500 megabits per second. What that means in practice is if you've got standard OS update file for a GMS image is around about 1.4 gig, and that will transfer in 2 minutes or less using a 2x2 MIMO Wi-Fi Direct connection. If you look at some of our lower end devices like TC21, MC2100, those have a 1x1 MIMO design, which is going to give you at least 50% lower throughput. So obviously your update time on the lower end device is going to be longer Even if you use it, say TC52 as a host device, it's going to be limited by the 1x1 MIMO design on the client device. So if you want maximum speed, then you want to use 2x2 MIMO devices. So for example, two TC52s connected together through Wi-Fi Direct will give you the minimum transfer time for the OS images. So why would you use Wi-Fi Direct on Zebra devices? This is really targeted for situations where a customer requires an OS update to devices in the field, and it might be necessary to visit each site in order to apply the update. So if you have devices scattered throughout a region or a country, and say in a retail store, typically retail stores have got pretty poor bandwidth on the actual Wi-Fi infrastructure. So what this would allow you to do is to take a Zebra device to that site, configured to do this upgrade, and then provided you can access at least the StageNow client on the devices to upgrade, you can connect them to your host device and you can download and apply the OS images without touching the existing infrastructure. The alternatives to that, you could use an SD card, for example. You could use ADB, but those tend to require more manual intervention on the device, in that you have to, for an SD card, you have to remove the battery, plug in the card. For ADB, you have to plug in a cable. Maybe you can do that, if that's available, that can be an option as well. But this is a wireless only option that you can consider if you need to do fast updates. Wi-Fi Direct, the summary is it will provide a faster local hotspot for OS updates, supported on all current generation Android products. In fact, I think Wi-Fi Direct has been in Android since version 4, KitKat, so for quite a long time. And as I mentioned, you need to be able to access at least the StageNow client in order to be able to do the upgrade. So if the devices are locked through some kiosk utility, you need to be at least able to get into admin mode in order to access StageNow. So the way this works is we will use an XML profile to update the devices, and that XML can be created in any of the following ways. So you could use StageNow, basically add the CSPs, the blocks that you need in order to download and apply the OS image. So build your profile and then export the raw XML. That would be one way. You could use a standard text editor, like, for example, Notepad++, and then you can just basically cut and paste the required XML into a document. And you could also use the OS Builder utility that I've created, which will basically automatically generate both the XML and also the UPL file with the correct file names and paths. So that really is a kind of simple way of building these profiles without having to do any particular manual editing, either in StageNow or in a text document. Profile itself contains the following steps. So the first step that's in the profile is Condition Manager, and that's checking that the battery level of the client device is at least 30%. Otherwise, it's going to stop processing the profile. And the reason for that is because when you apply an OS image, if your battery is less than 30%, it will fail at the point where it starts to apply the image. So if you put the Condition Manager check in before you transfer the image, it's more efficient because it will say your client device doesn't have enough battery, it's not worth loading the OS files. So that's just the first step. Then you've got a file manager step, which will transfer the OS zip file to the device. So it's from the host device to the client. We've also got an optional second file manager step, which will transfer the lifeguard zip file if you want to apply both an OS image and a lifeguard patch at the same time. You can do that. And then the third file manager step transfers the UPL file, which is basically the script file. It's just really has the names of the different zip files it needs to apply. And then finally, the last step is the power manager call to either upgrade or downgrade the OS using the UPL file that you've already transferred. So that's basically the contents of the profile. Because on the host device we're going to run a local HTTP server, we need to use this particular format for the file path. So the host device is always going to have a fixed IP address of 192.168.49.1. It's using port 12345, and then you have this path to the actual folder on the device where the files are going to be kept. So I put them under the Stage Now folder on the device because it kind of makes sense to do that. It doesn't have to be there, but if you use this OS Builder utility, it's going to build paths based on putting files into that folder or into a subfolder from that folder. And destination is always going to be a /data tmp public. That's the folder on the device which you can write to, which we use for this type of OS update. So basically on all the file manager steps, it's going to copy from the source path to the destination. And the UPL file itself contains a list of the OS files that you want to apply. So if you're doing a full OS update package, you put that in the first line of the UPL file. And then optionally, you've got the second line, which contains the lifeguard patch file name. So in this case, it would be both an OS update and a lifeguard patch applied. Obviously, what this doesn't do, and if you were listening to Darren's talk earlier, you will have seen that in Stage Now, you can build OS profiles for staging from a Stage Now PC. If you do that, then it does things like checking to make sure that it will guarantee effectively that your lifeguard patch is matched to your OS update file. This is a much more manual method, so you need to make sure yourself that the lifeguard patch you're applying is actually appropriate for the OS file that you're applying. So if you're doing Android 10, you need to make sure the lifeguard patch is for that particular version of Android 10. And as I mentioned, the simplification of this process is provided by an unofficial, as in unsupported utility I've called OS Builder. That will basically automatically create the required raw XML profiles for either upgrading or downgrading through those methods. So yeah, as I said, the first step it will always include is the check for the battery level. And it's got a very simple user interface, which we're going to look at. You can download it from this link. So just use the highest numbered version that's posted in that folder. Unzip that to a working folder on your PC. So, for example, OS Builder. Run the osbuilder.exe file. It has a dependency on the .NET framework. So if that's not already installed, it will prompt you to install that. But otherwise it will run, and you can basically then at this point enter your project name. That's going to be whatever you want to use, but I try and use a sort of naming convention that makes sense. So in my case, I'm going to use the model code T for an SD660 device. I'm going to use the 10 as the Android base OS version, Android 10. 1610 is the actual Zebra build number, and then a U number followed by a number is the lifeguard patch version, and then I use either down or up to indicate whether it's a downgrade or an upgrade. So I think that makes sense to me. You can use whatever convention you want to do it as long as it's meaningful to you. So demonstration, we will drop out of there and go to the actual app. And so in this case, what I'm going to do, I've got a device here which is running Android 10 and currently has, I think, U44, Lifeguard 44 installed. So what I'm going to do is to upgrade that to the latest patch, which is U70. So in this case, I'm going to use the project name T10 because it's Android 10. 16-10 is the base OS version. U70 is the Lifeguard patch, and it's an upgrade because I'm going from 44 to 70. So I just enter that file name, hit create, and it should create a folder for that in the working folder, the same folder you installed the utility. So then I hit upgrade, and in this case, I'm going to select an OS file. So it says OS, but it's actually can be an OS or a Lifeguard patch. So I go to 1610, I select U70, select the patch file. It's going to copy that now into my working folder, my project folder, sorry. And you can see here that it's added the actual XML to be able to transfer that file onto the device. And then at that point, I just have to select whether I want to do an upgrade or a downgrade. So in this case, I'm going to select upgrade. And at that point, I can just hit exit. And it just tells you copy that folder to the SD card stage now folder on your host device. So I hit OK. I go to that working folder. You can see here, this is the folder that was just created with my UPL file, my XML file. And if I look at the UPL file, you can see it's just got one line, which is to apply that Lifeguard patch. So all I need to do now, I've got a EC55 connected here, which hopefully you can see the screen of. So this is already using the utilities that you need to install on the host side. And what I have to do is just transfer the files to this device, which hopefully I can do. So just go into stage now. You can see I've already got some there, but I'm going to take that folder, the 70 up folder, just copy that, paste it into here. Okay, it's already got one there. Let me just delete that so I don't confuse things. Paste. And at that point, then that's done. So I can turn off the file transfer. And you can see here now, basically I've got these apps which are numbered. So the first thing you do is check that the HTTP server is on. So by default it will be off. You need to make sure that button says on in order for it to work. PDAnet is providing the Wi-Fi Direct hotspot, so I need to enable that. Sometimes you get that message. Just try again if you get that, and it should enable the second time. So set up the hotspot. That's my hotspot SSID, and that's the password. So what I could do is on my client device, I could search that network and connect to it manually. In my case, what I've done is there's actually a utility here which I can use to build the profile. So if I put in the name of the SSID and then the correct passkey and then hit generate, it will generate a barcode to connect to that particular network. Or in my case, for this demo, I've already got that XML profile set up here. So I can just say display barcode, take my client device, run stage now, and then just read that barcode. And at that point, it should connect to my Wi-Fi Direct hotspot. And if it does, you'll see that there'll be a MAC address appearing in that blue band, which you can see there. It says connected and waiting. So that connection was good. So then I go back to StageNow Mobile, which is the utility to actually build a profile barcode. Go into StageNow, go to my upgrade folder that I copied over. And I've got one XML file, just click on that, display barcode, take StageNow on the client device, read the two barcodes, and then what you should see, hopefully, is it will transfer the OS image, which it did very quickly because it's a lifeguard patch. Hopefully you can see that in the camera, but basically that took about 2 or 3 seconds. The patch size itself is something like, I think, 70 meg. Yeah, 70 meg, so it's very fast. And that was it. That was the patch applied. So we go back to presentation. So the slides here just walk you through what we've seen there. You enter your project name to create a new project. You browse to the either the full OS update zip file or the lifeguard patch. So if I wanted to do that same process, let's go back to the utility. Where's it gone? Stopped. Run that again. If I want to do a full OS update with a lifeguard patch, let's say 16-10, and then say 44 down. So in this case, I'm going to downgrade to 16.10 with patch U44, create that project. In this case, OS file. First, I apply the base image, which is 16.10.0. It will take a while to copy because it's a 1.4 gig file. So you just have to wait for a while it's doing that copy process. And after that's completed, then I can also add the lifeguard patch. Just take a while. Okay, so then I can select OS file again, U44. That will be quicker because that's just the lifeguard patch. And then in this case, select downgrade and exit. And in that case, then you've got your UPL file, which contains the two packages, the base image and the lifeguard patch. There. So the other thing I wanted to mention is that you can also do streaming upgrades and downgrades. So in that case, what you would need to do is from the OS upgrade menu, don't select OS file, just select either stream up or stream down. This will only work for MX 10.1 and later devices, so it's really for Android 10 or at least Oreo with MX 10.1, and you need to only apply an OS update, so it can't work with with lifeguard packages. It has to be a full update. And where it's useful is if you have a device which has a small flash memory of 16 gig, which is present on some configurations of our devices, like for example PS20 personal shopping device. Quite a lot of the ones in the field have got a 16 gig flash config. And in that case, you may not have sufficient memory in storage to actually download the full OS image. So if you have less than 1.4 gig, you won't be able to do the traditional downgrade the image and then apply it. Whereas with the streaming upgrade or downgrade, you can upgrade any or downgrade any device, regardless of how much flash memory it has, because it's going to stream that update direct to the device and apply it as it's streaming. So it's a useful feature for small memory devices. The overall reflash time is about the same as if you download the patch first and then apply it. So you don't get a performance increase in terms of the speed of the process. You do get a notification in the notification bar, which tells you that gives you a percent indication of the how far it's got. And one important point: if you have an interruption of the stream, so for example, say battery goes flat on either side, then you won't cause a problem for the device, because the way this works is that you have this AB partition, flash partition. So you have one active partition, one backup partition. The streaming image goes into the backup, and it's only when it's completed streaming the full image to the backup that it switches from the main to the backup partition. So it's basically been designed to be fault tolerant, and it will still reboot with the existing image if you have a failure when you're streaming the new image. On the host side, we saw the utilities that I showed you on the EC55, and those were installed through this barcode, which is an internet hosted StageNow profile, and that basically installs Enterprise Home Screen with the required utilities. So those are the HTTP server, the PDA-NET application, the Wi-Fi connection utility, which will allow you to generate the Wi-Fi connection barcode, and the StageNow mobile application, which will allow you to generate either a StageNow barcode or an NFC tag, or you can bump two devices together. My recommendation is to use the barcode because the NFC support is variable depending on the OS version that you have installed. So it tends to be more reliable, a lot more reliable if you use the barcode rather than NFC for this particular application. And just to note, you can quickly exit from EHS if you need to get out to the full device OS. If you hit the tools menu, there's a utility that James, my colleague James, who's doing presentation this afternoon, put together, which allows you to toggle quickly between the default launcher and EHS, just for demonstration and test purposes. So you wouldn't use it in a live deployment, but it's very useful to be able to quickly exit from EHS in order to access other apps. So these are the steps. We had run through these, but just to ensure the server's running and enable the Wi-Fi Direct hotspot. Use the Wi-Fi connection app to generate your Wi-Fi profile barcode, and then run StageNow mobile in order to select the XML file and display the barcode or the tag for that particular profile. On the client device, really nothing to do apart from just make sure it's connected by either manually connecting to that network or by scanning the StageNow barcode. If you get a problem on the client side whereby the download fails, then first thing to do is check that the HTTP server is enabled, so make sure that button shows on. And the second thing is that you can have a routing problem sometimes if you have other connections, either a WAN connection or another Wi-Fi connection active. So in that case, after you've connected Wi-Fi Direct, if it's still showing an error, do a reboot of the device, the client device, and that will normally correct any routing issue and allow it to connect to the server. And when you look at the server screen, if your connection is working, you will see there's a log. I'll probably show you on the, just exit from there. On the device, if you look at HTTP server, you can see there's a log here. It shows you all the different connections. So you'll see the last entry in that log is the last file that was requested, which in my case was the UPL file for that lifeguard patch. So it does give you that visual check that it is actually transferring files. Just some videos. I think that one is just running through what we've seen, just in case there was a technical issue with demonstrating it live. But in this case, it's using NFC to generate the profile, and this is so that's the host side, and the client side you can see here just in more detail. So that's connecting to the Wi-Fi Direct hotspot. These aren't in sync, so just ignore that one. So you can see that Wi-Fi Direct connection there, and it gives you the name of the connection. And then the second scan is actually starting to apply the profile, the OS update profile. 2 barcodes. You can see up here, well, in this case, you've got the download progress indicator, which tells you immediately whether it's working or not. So it's downloading the full update. This is actually two by two MIMO devices, so this is running at full speed. And you can see this is the 1.4 gig file. It's already got to 40%, only in 59 seconds there. So it is really fast when you're working between 2 up-to-date devices. It will really transfer the images very quickly. And after it's completed that, then you should see, in this case, it's doing downloading the image first and then applying it. So you should see through the notification bar that the image is being applied. So that's finished. And then, yeah, you see the OS update indication there. So I didn't leave it running all the way through because that will take quite a while. It takes about 4 or 5 minutes to apply that before it will start the reboot. So how do you modify an existing profile? What you have to do is, so what we're talking about here is changing the action from upgrade to downgrade or vice versa. So if you look at, let's have a look at the code for this one. This is the one that I just built, which applies both the OS base image and the lifeguard patch. And you can see in here that it's doing, this is the last step, which does the actual OS reflash, and the reset action is 11, and 11 is downgrade and 10 is upgrade. So if I want to change that to upgrade, all I need to do is change that value to 10, save the file. I probably want to rename it to up instead of down, but that's just a very simple change, just to change that to do an upgrade instead of a downgrade. And these have to be correct, because if you try and apply an upgrade to a device which has a higher OS version already installed, then it will fail at the reflash stage. Won't even try and apply the profile, and same with the downgrade. So just, yeah, make sure, depending on what version you have and what version you want to apply, make sure you choose one or the other that's appropriate. And then second case of modifying is when you want to add a lifeguard patch to a full OS update file. So in that case, you've got 2 changes to make. Let's have a look at that on the original one that I showed you, which is the U70 up. So this at the moment is just a update of the lifeguard patch. I want to change that to also update the OS image. Then the first thing I need to do is to add the package name for the full image, which is this one. So copy that from there. It needs to be prefixed with package, colon, and then the file name. So I need to add that. And then the second thing is to add another file manager step to transfer the full image. So let's put that there. And I need to copy the file name again. Just that one. And paste that in to replace that one. And also there. So now I've got the full update image, I've got the lifeguard patch, and I've modified the UPL file to include both. So apart from the naming convention, which is now slightly wrong, then that should work fine. If you want to do an XML syntax check, just open the document with Chrome and it will tell you if there's any errors in the syntax. So if, for example, if I miss out a bracket, say I delete a bracket there, save that, reload that in the browser, tells me at line 13 it's expecting closing bracket. So you can just go back in, can fix that issue, save the file again, refresh the document, and that's the correct rendering. So it's just a quick way of doing that. Back to here. So yeah, this is just what we've just seen there. Just change the in the main XML, add this step to transfer the full OS image, and then copy the project folder to Stage Now folder and generate the barcode. And that is pretty much it. I might be a little bit early on my timing, but let me just stop sharing at that point, and I'll try and answer any questions. You can see if there are any. So thanks a lot. Take care.